Hello everybody, welcome to 100 Days of DSA Challenge and this is our day 11. So today I have solved linked list questions. So this is the first problem which I have solved today. This is palindrome linked list. On LeetCode it is like easy mark problem, right? And if I show you like which what is required in this problem. So we are given a head of singly linked list and we need to return if that linked list is palindrome. And you might be knowing what is palindrome, but if you don't, then let me tell you, palindrome is such a structure. Like if we read it in from left to right or right to left, in both the way, like the actual linked list will be same. Like if we go like 1 2 2 1 1 2 2 1. So from left to right 1 2 2 1 and from right to left it is also 1 2 2 1. So it is a linked list. Whereas if we take example of like this one that is 1 2 then from left to right it is 1 2 and from right to left it is 2 1. So that's not palindrome over here. So I have solved this problem with the help of finding out the actually we can solve this problem by brute force by you can say like making a totally new linked list. So how I can do that, how we can do that? So to do that we can simply see like initially we can go and while traversing each node in the linked list we are simply taking value out and we are putting that value in a string you can say or in an array and then we can uh, run a loop on that array and we can check like if that array is you know palindrome or not and then we can return the thing but there we will be using a O of n space in making array, right? So that will not be a very efficient approach in that manner. So we are asked to, solve this problem in O of n space and O of n time complexity. So to do that, we are not allowed to take any other, array or something like that. So without that, if we want to do, then I thought of this thing that if we find out the middle element of a string, if we do that, so after finding out a middle element of a string, then we can simply, make sure that we are changing. Let me give you example. Like let's suppose here we have a linked list that is 1, 2, and 3. Bear with me, I don't have like pen, board or something, so I have to write with the uh, pad of laptop only. So yeah. So let's suppose this is a linked list we are having. So I thought of doing this problem in such a way that I am finding the middle element, and after finding out the middle element, I am reversing from this portion from middle element to till the last. I am reversing it. So I am making it in this manner that it's 3, then it's like 2, and this is our 1, right? We are having this 1, and so we need to have access of this new head. So this will be head 2 H. This will be head 2, right? This will be head 2, and this will be head 1. So, and this will be pointing to null, whereas this 2 will be pointing to this only, but we are changing these these connections. And to do that, I will show you the code how I am implementing. So from then, if we have like access to this node, then we can traverse from here to here, and we can traverse from here to here as well. Like what we will be doing, we will be running a loop or while loop that until that our head to, this is the head to, not become null. Till then we will be going forward, and we'll be going forward here as well, like 1 2 3, and we will be comparing the values 1 with 1, 2 with 2, 3 with 3, and if we get any value which is not equal, then we will just simply return false that. So in this case, if you see it, we are having head 1, that is head only. uh, we are getting mid with the help of mid function over here. Let me show you properly. So here you can see this is the like get middle function, and this function helping us to get middle value. So now I want to get the starting node after reversing the second half of the linked list. So to get that, we are using a reverse function, and you can see over here, I'm simply reversing the linked list or the second half of the linked list. And how I'm doing that, I'm putting middle element. I'm putting middle element in argument of a reverse function, and from that particular node, I'm running a while loop that I will go further till we have current. And if you figure out like what exactly you need to dry run it, and you will ultimately find out that pre will be the starting node of the reversed half. So this will be stored as head 2 over here. And now until we are not getting head 2 as null, we will be running a while loop, and we'll check whenever we get any value that is not equal to the initial head, then we'll simply mark answer as false, and we'll break down from there. And if that's not the case, then we'll move forward head 1 and head 2. And ultimately we don't want to change the proper linked list, so we will reverse function will be used over here as well. And now we'll be putting a rev start as an argument in this function, so that whatever we have changed, we want to make it as it is, which was there initially. So with the help of the last thing, we'll get similar to this. So this will be moving to here, this connection will be moving to here, and this connection will be moving to null. So that's how we'll be doing it. So that is the first function. I hope I was able to understand, make you understand the approach. There is the remove nth node from end of list. So to do that, I guess I have done some problem in past, which where I was deleting some or removing some node from the initial part, but here it's very simple. We'll I'm initially finding out the total length of the linked list, and after getting total length, that is count, we are storing the length in count. After getting that, and suppose we get a uh, total length of the linked list, then we'll find out the value which will be n. N is the position which we need to remove from the end. So we will subtract that from the total number of nodes, and then we'll get value. And I'm starting I or initializing I from 1 and putting temp or like connecting to head or equating it to head. Then I'm running a while loop. Will increase I and will increase temp until I is less than 1. And we'll find out that temp will be just at the position, right? Just at the position where we want to, not just at the position, it will be just before the position. Like in this case, if you talk about, it will be at 3 as we want to remove 4, so it will be at 3. So we'll be the next pointer of this node will be moving to 5. So in this case, this is how we'll be able to implement. And if it is like n is equal to count, that means we need to reverse the first node. Not reverse, we need to remove the first node. So if we want to do that, or if we need to do that, then I can simply return head dot test. Yeah, I'm not changing the head over here, but yeah, that will work for us. So in this case, this is the solution. And similarly, if I talk about this question, we delete the middle node of a linked list. It is similar to previous question. If we want to delete the middle node, then we need to reach this case. Like in this case, we need to reach at 4, and we'll just connect this 4 to directly as to 1. And in this case, we need to reach till 2, and that 2 we need to connect to 4. So in that manner, we'll be able to implement. You can see I'm finding out middle previous. So previous element from the middle, I want to get that. After getting that, I'm just changing the connection from that particular node. So that's how I was able to implement this question as well. I guess it's not very difficult to understand. If you have any doubt, then let me know in the comments. I will try to, or I will definitely make sure that I can clear out things. So that's it from my side for day 11, and thank you so much for watching.